Okay, we've got a piecewise function defined by these pieces. This is the function when x is greater than 0, which is this blue graph here. And this is the piece when x is less than or equal to 0, sine of ax plus b. And when a is 1 and b is 0, the graph looks like this. So if we want this function to be differentiable everywhere, we need to be continuous and to also have the same derivative. It looks like we got a problem at 0. So if we could move this graph up this way so that the graph kind of could be drawn without lifting your pencil off the paper, that would be the first step. So this piece right here, we can't transform because there's no a and b, but the sine of ax plus b, we can get it to shift or transform because we can change the values of a and b. So to transform the graph of the sine of ax plus b so that this point moves up to here, we want y to equal 3 when x equals 0. So the sine, if we put 0 in for x, a times 0 is 0, sine of 0 is 0, so b has to equal 3. Essentially, that moves this graph vertical shift up 3. So the midline goes from 0 up to 3. Here's what that graph looks like. Now, for this graph, I've changed the value of a so that now we've got a problem with the tangent lines at 0. So for the sine of ax plus b, this green dashed line is the tangent line. This red dashed line would be the tangent line for this g function, except for the fact that this function really isn't defined when x is 0. But this is the derivative of this function. And as we take the limit as x approaches 0, actually from the right, we get 1. Well, we'll talk about how you arrive at that answer on a subsequent board. But assume for now we know that the limit as points on this graph approach 0 for the x coordinate, the tangent line or the slope of the tangent line approaches 1. So we want this q of x, the sine of ax plus b, to have a derivative that equals 1 when x is 0. So here's q prime, where the derivative of sine of ax is cosine of ax, and then chain rule. Derivative of the inside is a. So when x equals 0, we want q prime of 0 to equal 1. So a cosine of 0 is 1. A times 1 is 1, so a has to equal 1. And here's what that looks like. Well, go to this board. Okay, so when a is 1 and b is 3, we get a graph that looks like it's continuous and differentiable at 0, 3. And this table kind of shows some possible y values for f of x and some slopes of tangent lines for the same values of x. And by the way, here's an example of a tangent line at other points on the curve. You can visit this graph and use this slider on P and see that we'll still get a tangent line at any point on the curve. Okay, so let's go back to here. I'll just let you read through this. This is kind of how you show that the limit of this portion of the derivative, that first term, is equal to 0. So the limit is 0 plus 1 or 1. That's the slope of the tangent line for the function on the right as x approaches 0. Okay, this is a little bit complicated, but we're using the fact that the exponential function grows faster than the power function. You might want to use the mnemonic aid FEPL. This is factorial. This is exponential. This is power. This is logarithmic. And we go from grows faster to slower. So when you have power over exponential, this guy's going faster. So it'll dominate the power function. So the limit is 0, limit, as x approaches infinity. There you go. Hope that helped. If you have any questions, post a comment.